Hello everyone and welcome to Teach Me channel. My name is Hubert and today we will be learning about GCSE chemistry states of matter. Now what we are going to be talking about, well, matter, everything on our planet can exist in one of these three particular states depending on energy state of the items, of the molecules. Depends on how much energy the molecules have. That depends what state of matter they will be in. Now, state of matter, there are three different states of matter. So I'm going to write them down. States of matter. There are three different states that we need to understand. One is solids, one is liquids, and one is gases. So those are the three states of matter. So you probably have witnessed all of them. You have witnessed things that are solid. For example, anything, block of wood is solid. Say a chunk of iron. You can find something made out of iron, that's solid. Liquid water is a very good example of liquid. And gases, for example, the air we breathe in contains oxygen, which is in a gas form. So everything that is in our world is in one of those three states of matter. Now, what do those states of matter depend on? Well, these states of matter are determined by, I'm going to write it down, determined by, well, these states of matter can be determined by material, because different material, different molecules have different strength of forces between them. They have different interactions between each other. So different molecules will have different thresholds at which they switch these states of matter, different melting points, different boiling points. And the way they switch these states of matter will be different. For example, ice is a very different solid to solid metal. And that's down to the unique properties of water and unique properties of metal. So these two solids have unique properties and they are actually different. So material can determine the states of matter. Another condition that can sort of contribute to the states of matter is the temperature. That's the obvious one. Temperature. Because the higher the temperature of a molecule, the more energy it has, the more it moves around. Therefore, the higher the temperature of a molecule, then the more likely it is going to change the state of matter into one of those that allows molecules to move around more. We will go over that, so if you don't get it yet, do not worry, we will go over that. But temperature is a very important contributing factor to deciding the state of matter of a given molecule. Now, the final factor that affects the states of matter will be the pressure. Now, this is similar to temperature in a way, because in the way that we have increased temperature allows molecules to move more. If we increase the pressure, we force them closer together. So we will favor the states of matter that allow less movement of a given molecule, which we will go over in a minute. But those are three most important contributing factors to state of matter. Going to underline these real quick. Bam, bam. Okay. So now, without further ado, let's get started on some actual states of matter. So, First one up will be solids. Now, what are solids? Well, solids are a situation where the molecule is held by strong force. The molecules are held to each other by strong forces of attraction, which keep it in fixed position. So if we had a solid, then the molecules would be arranged somewhat like this. So they would be arranged in neat rows, and they would be arranged in a fixed position. So they have strong forces which are pulling these molecules. They're pulling these molecules together. They're pulling these molecules together into fixed positions, into very determined, very precise, fixed positions. So that's important. That's why solids are solids. That's why it's hard to change their shape. That's why they sort of have a definite shape. Solids have defined shape. And that's all down to these strong attractions. Now, these particles, while they cannot move around freely, they do vibrate a little bit because they do have that energy. So they're held in place by these strong attraction bonds, but they do vibrate a little bit. They do vibrate a little bit. And the more energy they have, the more they vibrate, the more they move. So the more we heat up the solid, the more these particles start to move, the further they start to vibrate. And that's important. So vibrate more if temperature increases. Okay, so that's solids. So they have a strong, so they are held together by strong attraction forces, which keep the molecules in fixed position and give them the defined shape. Okay, so that's solids. Now, what happens if we heat up that solid? If we keep heating up that solid more and more and more and more, these molecules start vibrate more, they start moving around more, and then eventually that solid will melt. And what does that mean? That solid will become a liquid. So let me write that down quickly. There we go. Okay, so that solid will become liquid. Now, liquid, because they have so much energy, these molecules are moving around so much. They're moving around a lot, and what happens is that they overcome their fixed position. They overcome these very strong attraction forces, and they get out of their fixed positions. So liquids will look somewhat like this. So they are still close together. However, they can move around. They can move around much more than the solids can. And they no longer have fixed positions. No longer they have fixed position. Liquids are attracted by weak force because they already overcame that strong force. So they are sort of held together by the weak force. So they're still kept together. They still like to stick closely together with each other, but they no longer have fixed position. They're free to move past each other. So they do not have fixed positions. what goes with that is that the liquid does not have defined shape. No defined shape. So what it means is that obviously liquid does not have its own shape. So liquid fills the shape of a container it's in. If we pour it into a bottle, it will fill the shape of the bottle. If we pour it into a mug, it will fill the shape of the mug. If we pour it into, I don't know, a hip flask, it will fill the shape of the hip flask. So liquids do not have defined shape. However, they do have defined volume. Do have defined volume. Because we did not produce more molecules, the liquid still has the same amount of molecules, they're just moving around a bit more. And on average, the distancing between those molecules is equal, so they have a defined volume. The liquid has certain volume, and no matter what container we put all of that liquid in, it will have the same volume. So this is what happened with liquids. Now, the hotter the particles get, the particles move. I probably should put that down. Moving particles. Now, the hotter the liquid gets, the more we heat it up, the more these particles move around. The more they move around, the more they move past each other, the further away they move from each other. And past certain point, when we keep heating these molecules up, they will boil. They will become gases. And that's the final state of matter we will be looking into today. So gases. Let me underline that quickly. Okay. So that's the final state of matter we need to look at today. Now, with gases, the molecules are very far apart from each other. They're very far apart from each other, and they move in straight lines like so. So, why they are very far apart? Because that additional energy allowed us to overcome those weak forces in the liquid, and now gases are held by very weak force. So we overcome those weak forces, and now these gases are held together by even weaker force because they are further apart. These molecules are further apart from each other. So they're not attracting each other as strongly as they used to. Now, because they are held by very weak forces, the particles move a lot, and they move in straight lines. Particles move in straight lines. Because they're very far away, nothing is sort of pulling them back, not much anyway. They can just travel onwards in a straight line. Now, gases have no defined shape. As before, as with liquids, no defined shape. Now, that is because they're so far apart from each other. So similar reasoning as with liquid, they're not held together into some sort of definite shape, and they will fill a container. They will fill a container. If we put gases in a sort of a gas cylinder, they will fill it. If we put gases in a balloon, if we put air in a balloon, then that air will fill it. So gases fill containers, but gases also have no defined volume. No defined volume. Now, this one isn't entirely true, but as far as you're concerned for GCSE, they do not have defined volume. That's because they are so far apart. The volume can change. The volume can vary greatly depending on slight changes in temperature. and depending on changes in pressure. We can easily compress those gases by increasing pressure. We can easily increase their volume by increasing temperature, by pushing them further apart, these molecules. So, yes, at a given temperature or at a given pressure, they will have their defined volume. But as far as you're concerned for GCSE, because these volumes are so easy to change, gases have no defined volume. So, this is it for today, guys. Thank you very much for watching these videos. I really appreciate, guys, every time you watch these videos. If you want to stay up to date on daily maths and science and biomedical science videos, smash that subscribe button below. If you like this video, which I hope it has helped you, give me a big old thumbs up. And if you have any questions whatsoever, ask away in comments, and I'm more than happy to answer them for you. I love answering your questions. Thank you again, and see you next time.